So how do we distinguish between different optical isomers? The way we do that is with a machine called the polarimeter, which uses something called plane polarized light. So we talked about before how enantiomers have identical physical properties except for the way in which they rotate plane polarized light. So if you think about unpolarized light, represented here, you'd have waves of electromagnetic radiation that are coming in at different orientations. So I'm trying to do that here on my two-dimensional thing, but they could be coming in at any angle, right? So this is what this is showing, waves up and down, side to side, but also angled. Okay, now when you send that through a polarizer or polarizing filter, sort of like polarized sunglasses, that filter only lets through waves in one orientation. All the rest get blocked. So in this example, we can see that after the filter, we only have waves that are going up and down. So this is now plane polarized light. You don't really need to be able to define that term, but that's a term you should be able to use. So polarized light is just light that has waves all in one orientation. And then you have a sample. Usually this is like an aqueous or a liquid sample of your molecule. And let's say in there we have one enantiomer. We have one of these non-superimposable mirror images, one of these handed molecules. It turns out when this kind of light hits them, their asymmetric nature actually interacts with the light and causes it to get rotated off of the plane that it started on. So if we think of it coming in straight up and down, afterwards, it's no longer, so you can see the black line represents straight up and down. It is no longer straight up and down. It's been rotated in this direction by some angle. We'll call it theta, okay? So enantiomers, single enantiomers will rotate light by some angle off of the plane that it comes in on. And the two different enantiomers rotate the light by exactly the same amount, but in opposite directions. So if one enantiomer rotates it to the right by a certain angle, then the other one rotates it to the left by that same angle. So keywords here are that they rotate, they don't absorb or emit or any of those other words that we're going to associate with light. They rotate, plane polarized light in opposite directions, or by exact opposite angles. Okay? And this is how we can distinguish samples that have the different enantiomers. Now, if we put the enantiomers together in a 50-50 mixture, that's called a racemic mixture. That's a good term to know, a 50-50 mixture of two enantiomers. Well, what happens here is we get no net rotation of the light because one isomer is giving us the rotation right and one is giving us the rotation left. And the net effect is that that cancels out. So a racemic mixture has no effect on the plane polarized light or won't show any rotation. Now, if you have a bit more of one isomer than the other, then you'll get some rotation in the direction of the one that you have more of, but not to the full angle that it would normally be if you just had a pure sample of the enantiomer. So these are some mark schemes that give you how two enantiomers can be distinguished. You can see that you can have a simple answer like a polarimeter. That's the name of the machine, and the plane polarized light rotates in opposite directions is pretty much a good enough answer for how do you distinguish enantiomers. Again, the next one down, polarized light shown through. Enantiomers rotate the plane of polarized light left or right or in opposite directions by the same amount. So you can see pretty much the same mark scheme answers on two different tests, both of those worth 2 marks. At the bottom here would be a different question about enantiomers, which is that their physical properties are identical except for what they do to plane polarized light. And their chemical properties are identical except for with other chiral compounds. So that must have been a question that had to do with how do two enantiomers different in their physical and chemical properties and how can you distinguish them. Okay. And so those are, that's really all you have to know about how can you distinguish optical isomers from one another. You need to use a device called the polarimeter, which uses plane polarized light. and different enantiomers will rotate that plane polarized light by opposite amounts, opposite angles. And if you have a racemic mixture, a 50-50 mixture, it will not rotate plane polarized light.